Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam LTAM from the last spring 2019 course LTAM examination. Problem number 1 in multiple choice section. You are given the following information about a select and ultimate mortality table. The select period is 2 years. The mortality rates in the select period are equal to 75% of the standard ultimate life table rates. Ultimate mortality follows the standard ultimate life table. Calculate probability that a life selected at age 68 will survive 12 years. And here's the solution. Note that you can find the standard ultimate life table at smarturl.it/SULT. The old table, the one used before the recent changes in exam, when exam LTAM was introduced, before that we had exam MLC, so the old table was the illustrative life table, or ILT. That old one you can find at smarturl.it/ILT. So we have this life aged 68, selected at that age. We're looking for probability of survival for 12 years. That's a probability of survival for 1 year for that life selected at age 68. Then another year as a life selected at age 68 that survived 1 year. And then after 2 years, the mortality or probability of survival reverts to the one that is given in the table. And then that's equal to the probability that 68-year-old selected at age 68 survives a year. And then this next step, you need to think about it a bit. Why did I write that probability of life selected at age 68 a year later is the same as probability of survival for life selected at age 69? Because the probability of survival throughout the select period is just the mortality rate. Actually, the mortality rate during the select period at any age is equal to 75% of the mortality rate in the standard ultimate life table, which means that being selected at age 68 and then looking at mortality rate 1 year later for that person, it's the same as being selected at age 69, because it's always 75% of the standard ultimate life table, the mortality rate, the Q, not the P. So we write this as 1 minus 0.75 Q68 times 1 minus 0.75 Q69 times, and we need to figure out the probability of survival over 10 years for a 70-year-old. And there are two ways of doing this. One is to take the value of pure endowment at age 70 for 10 years, and then multiply it by 1.05 to the 10th to cancel out the discount factor that is present in 10E70, because 10E70 is 10P70 times 1.05 to the negative 10. So if you multiply by 1.05 to the 10th, what is left is 10P70. However, you may wonder, why am I making one thing into a product of two things? Well, the answer is because 10E70 is in the table, in the SULT table. So now that we wrote it this way, we just take all the values from the table. Q68 is in the table, Q69 is in the table, 10E70 is in the table, and SULT table. We plug those into the calculation. We get approximately 0.8191, I'm sorry, 0.8197157. You could also just calculate 10P70 as L80 over L70, and that's the second calculation. I think this is slightly longer to work with. It takes slightly longer, but it's about the same, almost the same. So you can calculate it either way. The question of calculation of 10P70 can be solved either by using the pure endowment value from the table or by using the population size numbers from the table. We get the same answer. Well, almost the same, but close enough for the answer on the test, which is 0.8197, which is answer C. Well, in fact, the answer choice C is 0.81, I'm sorry, 0.82. So this 0.8197 is approximately 0.82. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.